Oh, here they come. Here come those beautiful little rectangles from all over the world. So excited to have people here. I'll give it another 30 seconds as people trickle in. One thing we love for people to do is type into the chat where they are from. That's always fun to see. Well, good evening. I am Dr. Ted Barnett, president and founder of Rochester Lifestyle Medicine Institute. I'm also the high-tech doctor with low-tech solutions, and a lot of people know me as just Dr. Veggie, which also happens to be my license plate. So we're so excited to have people coming tonight for our Lifestyle as Medicine for the Planet lecture. And tonight we'll be graced with the presence of Kathy J. Pollard, who will be talking about food and climate change. To just mention a little bit about some of our programs. We have our very own 15-day whole food plant-based jumpstart, and we've been running that since 2018. It's a medically facilitated 2-week Esselstyn-style nutritional intervention. We've had 2,700 people from all over the country and 11 different, all over the United States and 11 different countries take the program. We've had about 500 doctors refer at least one patient, and we get amazing results. So people who go through the program can expect to get off of their medication for diabetes, heart disease, etc. We also run the LIFT project, which is a slightly longer but less intense program. It meets 10 times over 10 weeks, 1 hour a week. And both of those two programs that I've just mentioned are also available to medical professionals for continuing medical education. Each one is worth 10 CMEs. We also have health coaching. We're very proud of that. And if you're interested, please check out our website, rochesterlifestylemedicine.org. We have a new program in addition to our Jumpstart Live, which we've been running since 2018. We recently launched Jumpstart On Demand, which is available wherever and whenever you are. And it's please take a look at our website for that as well. Kathy Pollard is a plant-based nutritionist and the author of the popular guidebook on health, climate change, and chronic disease around the world. Eating the book is called Eating Does It, Healing Ourselves and Our Planet with Food. It was published in November 2023. She's also the research projects manager for the American College of Lifestyle Medicine, otherwise known as ACLM, and one of the first nutrition instructors who taught for the renowned T. Colin Campbell Plant-Based Nutrition Certification course. You can learn more and read her articles, blogs, and interviews at kathypollard.com. Yeah, welcome. It's good to see you.
Thank you. Thank you, Dr. Veggie. And I hope everyone can hear me okay and see me.
Yeah, you sound great.
Hopefully you won't see me much, but
All right. Well, I'm gonna go blank here, and we'll see you when you're done. All right.
okay,
Great.
deal. I'm so glad to be here at the Rochester Lifestyle Medicine Institute. I'm thrilled to have an invitation to talk to you about food and climate as part of our LMI's Lifestyle as Medicine for the Planet series. And that's what we're going to talk about. We're going to talk about how food and climate change intertwine and how they both relate to personal and planetary health. And thank you for the introduction. That is who I am. I am Kathy Pollard, and I work for ACLM, American College of Lifestyle Medicine, in the research department. I do a lot of science writing. I run a lot of, we've designed a lot of programs, and you're probably learning about lifestyle medicine from from the Rochester group. And that's a great introduction with some amazing programs. You can see the picture of my book that is all about the topic that we're going to be talking about today. And enough about me. Let's talk about what we're going to talk about today. And we're going to start with talking about us, the power of humans, and how that affects our health and our planetary health. Because there are boundaries, and we're going to consider what those boundaries are for both. We're going to talk about the global warming potential of foods. And we're going to talk about the greenhouse gas emissions that come from food and other things that how humans impact our climate. And we're going to figure out how diet plays into that. And we're going to see if there is a particular diet that's best for both people and the planet. And we're going to talk about these two big challenges, which involve, our health, our personal health, and the health of our planet. And we're going to face those challenges and see if we can find some sort of solution. And we're going to figure that out together. So let's start with that power concept. Humans have we're in a place we've never been before because we have such capacity to create and build and heal and reproduce and survive for thousands of years that we have made an impact on both our personal health and our planetary health. But I got to tell you, there are boundaries to that. And when you push the boundaries, you go into an area of disease. And that's where we are. We have we're prone to disease both personally in our bodies and our brains, and we're also prone to disease on our home planet. And it's a point where we can't sustain business as usual because we're reaching our boundaries. So we're doing the same, with the human body. That's what's happening. That's what manifests disease, right? When we're pushing the boundaries of what our organs and what our body is able to handle. Um, it's harder to heal. It leads to inflammation. It makes us prone to disease, and it leads to illness and premature death and symptoms. So we're pushing beyond our boundaries. Let's start with the Earth's planetary boundaries. This is a concept that was developed in back in 2009 by a bunch of researchers from many different disciplines. They call themselves the Stockholm Resilience Center. And what they clarified were these 9 planetary boundaries that you can see here on the screen that basically control the systems and the stability of the Earth. And here they are, land, water, biochemical flows. We're going to talk a little bit about that, and the integrity of the biosphere, all the life on Earth, and the climate and the ocean. And the green part is our safety zone. And you can see this iteration is a newer one. It was created in 2023, and you can see the orange flares there. That indicates that we are pushing beyond our planetary limits in these areas. And you know, I just researched this again to see how the planetary boundary map has changed over the years because I hadn't looked at it since 2022. And by Jove, we've breached a couple more boundaries since then. I thought the most recent breach was uh, it's called novel entities. That was in 2022. That's basically toxins, chemicals, plastics in our oceans, in our land, in our atmosphere, and that was pretty scary to begin with. But in 2023, by Jove, we've reached another height, and that is that we've breached our fresh water boundary, which means that um, our fresh water, our surface and groundwater, and the water available to plants are beyond sustainable limits, and toxins are entering those systems. And we've reached 6 out of our 9. So you can see how things have changed really, really rapidly. And that's a pretty scary place for our home planet to be in. It's the same with our human body. We've got boundaries in our human body, and when we push beyond those that our organs sustain us with, we get sick. It's sort of the same thing. And one reason that both get exacerbated and sort of sped up is from feedback loops. So I just wanted to touch on this concept of loops, feedback loops, and just what that concept is like it's a repetitive cycle that sort of changes the outputs into inputs, and it repeats itself, which amplifies or diminishes a certain effect. So it's sort of where a system spins out of control. And we're going to just look at some examples. For climate, there are really clarified, known feedback loops. There are several of them. I think we have 4 or 5 here. One is evaporation, and as an example, it's really easy to visualize this. That when it's warmer, there's more precipitation in the air, and that warms the planet. which leads to more evaporation and more heat trapping water vapor in the air, which leads to more warming, and so on. So you can understand the spiral. There's another spiral that's similar with reflection. You know, white stuff reflects heat away from the earth, and um, uh, I'm sorry, white reflects the heat away from the earth, but when it's warmer and the white snow and ice melts, then you see darker landed water, and that leads to more absorption of heat instead of reflecting it away, and that increases the initial warming, and that's a loop right there. That's called the albedo effect. And the same you can see with thawing. And thawing is sort of important because there's a lot of frozen soil in the world, in the northern part of the world, that is sequestering a lot of carbon. And as that soil melts, it's permafrost, then that carbon is released, and that leads to more warming and more thawing, etc. So those are just some examples of climate feedback loops. Just to mention that there's a lot of that permafrost in Russia and Canada and the Antarctica, and we're seeing those areas melt. This was a sort of an earlier warning of climate scientists that we were really in for some quick warming that we have never seen before, and it's continuing at a more rapid pace now. Forest dieback, the loss of our forests from warming temperatures and droughts, keeps the earth is limiting the Earth's ability to absorb more carbon dioxide because trees hold carbon, and so that leads to further warming. Let's think about humans. What's a sort of a logical feedback that we can understand that humans participate in? Our everyday habits and our behavior and our diet, our lifestyle. If we have a good diet and we're conscientious about our exercise and movement, we get enough sleep, and we follow the pillars of lifestyle medicine so that we can um, keep our optimal health, that sort of feedback feeds back on itself, and we get to feel stronger, and we have a more enriching life, and we live longer. The go spiral the other way, couldn't it? So, in terms of feedbacks that humans create, can you think of some things that would spiral up or spiral down as a feedback? Well, there they are. Some social determinants of health, you know, where we live, how stable we are in our neighborhood, in our finances, in our education, in our social communities. That has a lot of effect on our health, and it feeds back on itself. I like to throw in air conditioning because that's a beautiful example of a feedback, right? When it's hotter and more humans are able to afford air conditioning and use air conditioning, we use more, and it's run on fossil fuels. So that leads to more carbon dioxide emissions and warming the planet. So those are some examples of feedbacks, and that's why both personal and planetary health can be either sped up or speed in the other direction, and illness can occur. It's a loop. So there are some solutions to that, and I love this slide because these are solutions that we can participate in. Now, of course, the first solution we've heard a lot about, which is we need to transition away from fossil fuel and transition towards sustainable, renewable, clean energy. Most of us know that and understand that concept, but there's another part to this transition, and that is having to do with our food and our agriculture. We need to transition to a predominantly plant-based diet, hopefully whole food plant-based diet. The global food system cannot sustain the amount of resources and energy that it takes to grow, produce, and process animal foods. So that's the height of the amount of energy and resources that it takes in our food system. And coming into a close second is processed foods. And that we've got to limit. We've got to limit these things for both our personal health and our planetary health. It's not just one, and it's not just the other. That we need to consider both of these big transitions, and it's really essential to the sustainability of our planet as well as our health. The good news is that what we choose to eat goes a long way. There are so many benefits to eating well. We're going to go over that, but I bet you already have a clue as to what eating well is. And that is a whole food, plant predominant diet with fiber in it. We're going to talk about that. And the best thing is that the good stuff starts right away. We don't have to wait for policies, or we don't have to wait for infrastructure to be built, or legislation to be passed. We can choose to eat optimally as best as we are able to right now. And we just need to think about it, eat smart, and there's no single action that will benefit us better to improve ourselves in our world, and that's the good news. In fact, it's just this concept is so simple, it sort of defies how broad these effects go when we take our own health and our own diet in our hands. So what is that diet, do you think? Well, we're talking beans, greens, grains, and fruit, maybe some nuts and seeds in there. We're talking a whole food, plant-based diet. Here's another picture of it. This is the American College of Lifestyle Medicine's whole food, plant-based food plate. And you can see that half of the food plate there on the left is vegetables and fruits. And then we want to add the foods with the higher amount of proteins. I don't like to call them proteins. They're because foods have a mix of macro and micronutrients, and these you can see are the beans and the nuts, and some legumes that some whole grains that are pretty high in protein, and then under them we have whole grains, which they have protein too, and they have carbohydrate, and they have lower amounts of fat, but they've got those macronutrients in them, and they've got fiber. In fact, these whole foods are the foundation of lifestyle medicine, with its ability to prevent and treat chronic disease. And you cannot do that with medications or invasive treatments. It takes lifestyle. Um, Whole foods are nutrient dense, they're calorically dilute, they're rich in fiber and antioxidants. They're made of a variety of minimally processed vegetables, fruits, whole grains, legumes, nuts, and seeds. And the evidence supports that this diet can be strategically used to prevent chronic disease and treat conditions. That's amazing in itself. But here's the problem. Oops, I'm going the wrong way. The problem is that the American diet is made up of mostly not this stuff, but of refined carbohydrate and processed foods and animal foods. And that's the problem. These foods don't support health. There's very little fiber in there, and the nutrients are not in the proportions that the human body is expecting to see. So let's talk about some of those concerns in terms of eating this way for our health. Well, bad carbohydrates in there. The bad carbs. There are two kinds of carbohydrates. They're the ultra processed formulated type of carbohydrates. They're the refined carbohydrates, and then there's whole carbohydrates, and those are healthy. They have fiber in them. The more processed you take a food, that started out as a grain, the more refined it is and the less fiber it has. It comes with fat, sugar, and salt in it, most assuredly. And that keeps us from feeling full and satisfied, and it keeps us wanting more. It's designed to make us want to eat more and eat more frequently. And that's the tragedy of processed foods. Animal foods has their issues in terms of health as well, because it's really easy to take in too much protein. Protein has a lot of issues with it. Taking in too much of the body's requirements not only yields excess calories, because if there's too much protein in there, the body's going to break it down and store it just like fat. But it's an acidic um, element, a compound in our body, and it has to be broken down and not only stored uh, as energy, but it's got to it's got to deal with the acidic breakdown of the digestion, which is the body doesn't like to be outside of its very narrow pH balance, and that creates a lot of issues. That protein needs to be broken down, and it needs to be excreted. That the acidic quality has to be excreted. It has to be buffered in order to get rid of it. And the buffers is calcium and our minerals. So there are a lot of issues. Of course, animal foods are a package of, fat, cholesterol, saturated fat, and protein all together without fiber. And that's really hard for the body to mitigate. Um, so they're calorie dense. They don't have fiber. And it's really hard for the body to get the right amounts of these macronutrients when you have animal foods in a big pile. It's sort of like, well, we're going to talk about planetary concerns, but it's sort of like um, a wildfire at once. It's like a big mega event to the body where, in a fire, there's a whole lot of carbon dioxide released at one time. And in the body, when you take in a protein, and when you take in animal foods, it's a whole lot of protein at one time, and it's hard for the body to mitigate that. Of course, eating this stuff crowds out the good stuff, and we don't want to do that. We want to get whole foods as much as we can. I'm going to touch on dairy, trying to be quick about it, but there are some dilemmas with dairy, and that is that we're taking in another animal's hormones, growth hormones, sex hormones, and cholesterol, and IGF-1 is a growth hormone that we take in a lot when we take in dairy, because we're taking, the formula that a little baby cow would need to grow into a really big animal, and that takes a lot of growth hormone, and there's a lot of estrogenic sex hormones in there as well that our body has to deal with. They're naturally occurring. Um, they 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 really are in amounts that are hard for our body to deal with. And of course, it comes in a package with cholesterol and fat. A lot of people are lactose intolerant because we naturally stop producing the enzyme lactase to digest this food, uh, because it's baby food and we grow out of it. So a lot of people have a hard time with that, particularly those of Asian and African descent, as well as Hispanics and Native Americans. They're largely lactose intolerant, and that leads to health disorders. And it's there's an element of disparity here when it comes to promoting um, uh, milk to the whole population. Some people have a really hard time of it, and then these conditions can arise with the constant ingestion of dairy. So I just wanted to point that out. We could talk about eggs, but that's just a cholesterol bomb, and it's very acidic food, and I'm not going to take too much time on that one. But just suffice it to say that we've got two categories here: processed foods. They're made to last. They've got all sorts of additives to make sure they have long shelf lives. That doesn't bode well in our body. There's some of them and animal foods. Animal foods are correlated with cancer growth because, hey, protein likes to grow things, and if we're not growing bodies, then it's gonna maybe find other things to grow. And it's the macronutrients in animal foods are correlated with other diseases as well, including cardiovascular diseases and autoimmune disorders. Animal foods have no fiber. It's essentially no fiber. That's really hard on the kidneys to digest. And there's a higher risk of death and an association with uh, um, uh, a predisposition towards earlier mortality, and also gut issues, because it's hard on our gastrointestinal systems, and it changes the bacterial balance in our guts. Um, Again, these foods crowd out the good stuff. We want to get the whole plants in our diet as much as we can, because many of these chronic diseases that we're so familiar with are driven by this type of food, as well as other lifestyle practices, including tobacco and physical inactivity and excessive alcohol use. Now let's just switch to the planetary concerns that we have. Our global food production contributes heavily to global warming, and agriculture, in fact, is responsible for a third of all human-induced greenhouse gas emissions. These percentages and ratios, they vary depending on the research, and there's so much coming out, and that has come out, if you're able to get a hold of it, that the numbers vary. Um, in that 33% of greenhouse gas emissions, 40% of it, according to the Food and Agriculture Organization, is from livestock, from big animals. That's a lot. The total emissions from livestock globally for greenhouse gas emissions, that number varies a lot depending on the research. This is, I think, a very conservative number, and we've seen other research come out with much higher percentages, up to 50% of total greenhouse gas emissions. So it really depends on the rigor of the study and what variables are being considered. And that's another discussion in itself. But let me tell you, 14% of greenhouse gas emissions is a lot. That's about how much all of our transportation, planes, trains, automobiles in our world, it accounts for. So livestock is up there with all of transportation. That's a lot, and that number is expected to increase, unfortunately, by 2050. And there's sort of no slow or halt in sight. But maybe we can create a revolution and make some change. Okay, quickly, let's talk about gas. I'm talking about greenhouse gases here. Methane is a very potent greenhouse gas, but it's doesn't last very long. It's only lasts around a dozen years or so. Carbon dioxide, on the other hand, um, lasts a long time. Now, people consider that methane is like a life is the main gas that livestock is responsible for when it comes to greenhouse gas emissions, and they do burp and belch methane, and their manure emits methane, and it's a powerful short-term gas. But what really accounts for the effect of livestock on this earth is the amount of energy needed to grow so much food for such big animals, and maintain their life and then the processing of them for their food. That's a lot of energy. That is what the effect, that's the bigger effect of cows on this earth, is the amount of energy that it takes to process them, to grow them and process them, if we must think of them as food instead of sentient beings. But when it comes to greenhouse gas, it's the amount of resources going in. So it's the carbon dioxide that is a bigger effect. And one reason is because it lasts. And methane, it goes away. It dissipates after a dozen or so years. And CO2 rules. So methane doesn't last very long. It's more powerful, but it's more efficient at trapping radiation. So it's more powerful, but doesn't last as long. Um, and it's emitted by lots of stuff besides cows. A nitrous oxide is a sort of an in-between gas. It's more potent than carbon dioxide, but it only lasts about uh, 300 times, about 300 years also. And it comes from a lot of different sectors as well. Um, I wanted to say that, I think my next slide, yeah, fertilizer has a lot of nitrogen in it. That's so that also is related to animal agriculture because fertilizer is for animal food, and then they poop and it's in their animal manure. So it has a shorter lifespan. Um, but so imagine that we've got these really powerful gases, but they don't last as long as carbon dioxide, which, it lasts, some of it lasts for decades, some of carbon dioxide lasts for, hundreds of years, and some of it, about 20%, lasts for thousands of years. And so it accumulates. And that's why carbon dioxide is the measure that all other greenhouse gases is measured against, because it just accumulates. And a whole lot of it goes up in smoke when we burn forests. And what do we burn forests for? Cows, palm oil, biofuels. Hopefully that's phased out more, but mainly for cows, all over Asia, Africa, South America. So that's carbon that's not going in the soil, it's going up in smoke. That is no photosynthesis in forests that is creating more trees and more plants to hold carbon. It's just fire going up in a one-time mega event, and you can't put it back in the genie's bottle. So that's one good reason to choose plants over animals. Consuming plants versus animals can reduce our global warming potential. Some estimates say that could reduce our potential by 50%. Um, and livestock food production is the most pervasive way we impact the environment. Not only do we create so much greenhouse gases, but it's the main source of nutrient pollution. It takes a lot of energy to maintain, biological living beings. Heating, particularly for poultry, they wouldn't survive without a very controlled environment. That takes a lot of energy. Um, GHG is greenhouse gas emissions, so you can sort of see, you can compare beef to poultry and beans. Beef creates 40 to 8 times more greenhouse gas than growing beans to eat, for instance, by some research. I just wanted to share that with you. But 36% of the calories produced by the world's farmers in total feeds animals. It just doesn't seem to be a very efficient way to eat and to produce food for the globe. Global warming potentials of food. This little table just shows the potential for different foods to create greenhouse gas emissions. So look at the top here. They're vegetables. And this has the smaller numbers, the least amount of global warming potential compared to animal foods on the bottom. So you can see that beef has the highest global warming potential there. And that's because it takes a lot to make a burger, to produce beef. It takes a lot of water. It takes a lot more land and soil and energy input and total energy use. It's the energy input to produce nitrogen fertilizer that is just such a resource sucker. And then it's the climate control for biological organisms. And we don't think of food that way. We're immune to that. We don't see that side of food production. We're not meant to see that side of food production. But we don't have to. We can celebrate whole plant food. And here's why. Taking a sip, hold on. My number one reason is fiber. Although whole plant foods have the right balance of macro and micronutrients, fiber isn't considered a nutrient because it doesn't have any calories, but it's a hidden nutrient because it is what keeps our colon healthy and makes us feel full. It's the scrub brush of our gut. It sucks up extra cholesterol if we don't need it. It feeds our good microbiome, the gut bacteria, the food that they want to eat down there, and it ushers out pathogens and parasites for us, and it keeps us regular. They're just, it's sort of a wonderkind, the silent, hero of food. So don't forget to give fiber a little respect. Also, leafy greens, they're the most nutrient dense foods on this planet, just filled with micronutrients. Those are the vitamins and minerals, but don't forget to eat the rest of the rainbow. Those colors are the same chemical properties of antioxidants. Those colors that you see in plant food, they're the antioxidants and vitamins, chlorophyll, and all these compounds that fight inflammation, and they suck up these free radicals, these compounds that molecules that are really um, unstable and mean, and they create bump into cells and they create cell damage looking around for their unpaired electrons. And so we make them naturally in our body and when we exercise and when we digest food, but we make a lot of them when we eat animal food because it's really it's hard for our body to break it down, and we need to have a steady flow of antioxidants in our system to clean them out. Uh, let's not forget beans. Populations from time immemorial have been based on a diet of beans. They've grown all over the world and they've been nourishing people and the soil forever. They bring nitrogen back into the soil and sequester nitrogen and carbon, which is really important for the makeup of all the microorganisms in the soil. So let us remember the fiber, the greens, the rainbow, the beans, and whole grains, which have fiber and nutrients in the bran and the germ and the endosperm. And a lot of minerals in whole grains. So we really need these foods to maintain our personal health and control planetary health, both in that package of whole plant foods. So, as a recap, there are four simple rules for personal and planetary health, which you can find on page 179 of my book, by the way. And we'll go into them more, which what the book goes into them more in detail, but I'm going to go over them with you right now because they're simple and fun. The first rule for personal planetary health is the more whole plant foods in your diet, the better. You can't go wrong. You can't overeat. It has fiber in it. One would explode before you eat too much broccoli. You just can't do it. It's the fiber and the water that's protecting us, the water in the food that the fiber holds. So get as much as you can in your diet. There's all sorts of recipes and tips for doing that in this book. And I'm sure Dr. Veggie has a lot through the Rochester Lifestyle Medicine Institute as well. So get his resources if you can. Okay, rule number 2, don't sweat the small stuff. And what I mean by that is, a whole food plant-based diet does not depend on perfection. We can, you could go to a party and have a cupcake or have something that you may not be happy you ate later on. Your health is not defined by a cupcake. It is defined by your whole dietary pattern. So don't sweat it if you eat something you'd rather not, or you don't feel well the next day about it. Uh, you're always going to have the next meal, and you can add more vegetables into your stew or your salad the next time. So make sure to keep a steady flow of those whole plant foods and don't sweat it when we're a little off the mark. And don't forget to eat the right of colors eat the rainbow every day because of those compounds that fight cancer and clean out the bacteria. It's really important to get a steady flow of those antioxidants. And here's my fourth rule, which is fun. Eat as much as you want. How many times in your life does someone tell you, go on, eat as much as you want? Well, because if it's all good food, then you're good. So this eat as much as you want thing, it has a caveat, and that is eat as much as you want of food as long as it has its intact fiber. Because if it does, then you know it's a whole food. It's not an animal food, and it's not a processed food. So that's the story of the 4 food rules for personal and planetary health. And I want to touch on one other thing before we close it off, and that is that we waste a lot of food in our society. In this country, we waste 40% of the food that is grown, that is produced. That is a lot of energy. That's a lot of energy at waste. And we do it in all at all levels, at the agricultural level, at the store, retail, buying, the manufacturing level, the consumer level. When we take it at home, when we get that food home, many of us don't consume all of it. And it's something that creates a lot of waste, a lot of greenhouse gas, and it's affecting our health because that greenhouse gas, of course, affects our our climate, our atmosphere, the amount of pollution that we live with. So it is a concern when it comes to sustaining a global food system. Um, Subsidies play into that because they make expensive food cheaper. And what are the expensive foods? Well, animal foods, meat and milk, and then close to that would be processed foods because it takes a lot of energy and it costs a lot to produce these foods. There's a lot of input that goes into them. The most vulnerable in both our personal and planetary health would be those who are geographically vulnerable. Um, and here's some around the world. And in the US, it would be, low-lying areas and communities, of course, communities that are at sea level or under sea level, like, for instance, New Orleans that got flooded. Um, so those are regions that are vulnerable to climate change, and those regions that are vulnerable to climate events are also vulnerable to health issues and health events because it's hard to come out unscathed when you're in a hurricane or a drought. It affects our health, it affects our access to health care, and those who are most vulnerable, of course, are those living in unstable areas in this time of climate change, and children, those living with disease, those experiencing poverty. So these are huge swaths of populations, and as the climate becomes more severe in these regions, there's going to be more and more migration and all of the ramifications that comes with that. There was an amazing, very detailed study that came out in 2019 called Food in the Anthropocene. Food in the Anthropocene. And they coined that word, which means, the period of time on Earth of humans. And the Eat Lancet Commission on Healthy Diets for Sustainable Food Systems was led by Dr. Walter Willett, and they surmised that food is the single strongest lever to optimize human health and environmental sustainability on Earth. And that's a really powerful statement because we all eat and we all depend on a sustainable food system in order to live a healthy life. Um, Safe operating systems of those safe operating food systems require a shift towards a more plant-based dietary pattern. That is what this research, this body of research, came out to clarify, and that we need to make dramatic reductions in food losses and waste, and that we need a diet that is based on plant-based foods. We need a diet that has those foods with fewer animal source foods because that diet confers both with improved health and environmental benefits. So that's a big, tall order for our global community to take a bite out of. But we really have no choice. We're all in this together. We all eat, we all make food choices, and we all are living with the consequences of climate change. So we need to be models. We need to teach our patients, if we're healthcare practitioners, to be responsible. We need to be the models of responsibility as well, because we have the most choice. I mean, if we're able to sit and look at the offerings of the Rochester Lifestyle Medicine Institute here tonight, we are able to make smarter food choices than most people on earth. So let us choose conscientiously. Let's make some simple changes towards the better as much as we can. Be a role model. And if you are a practitioner, remember your oath to do no harm. In fact, I think it's our ethical responsibility and our duty to find solutions to both personal and planetary health with the tools available to us. And we have those tools. We talked about them tonight, and they equal having a sustainable dietary pattern. So, the solutions, in summary, for both you and the planet is convert to sustainable clean energy and transition to a sustainable diet. It's not one or the other. It's both. It's not optional anymore, but essential. So dream big. Remember the simple four food rules that we talked about. And remember Dr. Willett's quote that food is the single strongest lever to optimize human health and environmental sustainability on Earth. And I thank you for your attention tonight. I will stop sharing my screen. I will open it to questions. And
Thank you so much, Kathy. This was really wonderful. Yeah, and I'm going to ask Dr.
you.
Dulal, Dr. Eliza Dulal, to come on screen here. She's going to help manage the question Q&A. We have some other staff members in the back, like Dr. Graff and Dr. Friedman. If they'd like to, they can also appear. But go ahead, Dr. Dulal.
Thank you, Dr. Barnett.
Yes.
So we have some questions from our audience. So first question is, if methane breaks down in 12 years, what happens to it? Does it add to carbon dioxide?
That's a good question.
Mm.
Methane breaks down to carbon dioxide. So we've got a chemist on our group. Yeah, thank you for pointing that out. A little bit of carbon dioxide. So it's nothing compared to burning down a rainforest or uh, the amount of carbon dioxide that accumulates. And again, the difference between these two gases is really how long they're hanging around. And that carbon dioxide, just a bit of it hangs around for a really long time. Methane goes away, but carbon dioxide accumulates. So methane breaks down chemically to carbon dioxide and water. And unfortunately, I wasn't the best in organic chemistry. So if there's a one who's better at that than me, you can explain that. But that does result in a little bit of more carbon dioxide from the methane.
But the benefit of the methane breaking down is that it's much more potent than the CO2 that it generates, correct? So the methane is about 300 times as potent a greenhouse gas as the
Mhm.
as the CO2 is.
The benefit of the methane breaking down quickly is that it goes away. It is a stronger greenhouse gas, radiation
Right.
attracting gas. I think the nitrogen oxide is 300 times, and um, methane is less. It's
Okay.
10 to 20%. I forgot.
Okay. All right. Well, maybe somebody can put that into the chat. Somebody will check with AI on that one. All right. What's the next question, Dr. Dalal?
Okay, so we have two questions from Ravi Ravichandran. So his first question is, what is the percentage of Asians who have lactose intolerant? Because growing up in India, I did not know about lactose intolerance.
75 to 90% of uh, Asian and African descent, people of Asian and African descent it's a lot. It's a huge amount, and that's why it's just discriminatory in my view. A lot of people haven't been diagnosed or have never been to a doctor and don't know that these gastrointestinal symptoms that they may be living with, or other effects of this this state is from their diet.
Thank you. And his next question is, does cooking reduce or wipe out antioxidants?
Some. That's a good question. Cooking wipes out um, the water-based vitamins, which are antioxidants, some, and then it enhances some other vitamins and minerals. So that's why it's good to have a mix, have some raw and have some, cooked vegetables in your diet.
Thank you. That was really helpful. And our next question is, why is the Goodland and Anhang paper disregarded, and why haven't the folks been talking about it?
Oh, the Goodland and Hang paper. Why is it disregarded? Is that the question?
Yes, yes.
So,
Right.
um, so I think he's referring to the paper that claims that I think that's the paper that claims that there's for 50% of the world's greenhouse gases is from livestock. And why has it been disregarded? Because some scientists, the climatologists, the scientists who've studied this intensely, feel that they were counting things that aren't that are assumed would be a variable. And in other words, one is that all of the land that is used for livestock and cattle would reforest and rewild, and that would mean that it would sequester more carbon, and that's not an assumption. We can't assume that we don't know what's going to happen to that land. We think that if that land doesn't have any cows on it, that we won't be producing as much methane and carbon dioxide and greenhouse gas emissions. But some scientists think that's an assumption. We can't count on that. I think there's some other variables. So I think it's a really good question. I don't think that research should be completely discounted. But it just goes to show that there's a range in there, and it's a number. It's a number in the atmosphere that's really hard to pinpoint, because it's not the same in every place at every time. It's air, so it's in the air and in the stratosphere and atmosphere, so it's really hard to measure. And I leave it to the scientists to do that. They have amazing models that have just gotten better. That's the other reason numbers are vary, because research modeling has changed and improved. And so research is evolving, and that's the beauty that's one of the beauties of science, is it gets
Mhm.
better. And scientists debate these questions all the time. It was a good question.
Yeah, by the way, I checked it. Thanks for the answer. I checked you're right. Methane is 25 times more potent
Someone said
molecule.
methane is Jerry says methane is 80 times more potent greenhouse
Well,
gas than carbon dioxide
it,
over a
it
20-year period.
right. In one instant, it's 25 more, 25 times more potent. But then he's right. Over 20 years, it's 84 times more than CO2, and over 100 years, it's 30 times more. So
Can I
it's
make a point? That's a really good point.
yeah,
Sorry to interrupt,
sure.
Dr. Veggie, but that's the other thing to consider, is the time period. Usually greenhouse gases are measured on a 100-year time scale, based on a
Right.
100-year time scale. So here methane is based on a 20-year time scale. And so it's 80 times more potent than CO2 in a 20-year time scale. So what does that mean in 100 years? It's gonna be less. It's gonna be a different number.
Mm.
So that's the other thing you have to consider when you're looking at these,
Well, and also
comparisons.
what's also really important to remember about that is that the next 20 years actually matters more than the next 100 years at this point, right? I mean, if the next 20 years the ice caps all melt, then kind of doesn't matter what happens right? 100 years from now. So that's why
Yeah.
the short term does really matter here.
Yes. So
Yeah.
2 points. Really
Yeah.
good, really good point. I have 2 things to say, if you don't mind.
Sure.
One is that that number isn't a hard and fast number. 80
Mhm.
times more potent than carbon dioxide in a 20-year period. It might be, for the first 10 years, 80 times or 60 times is potent. And then the next 20 years, it dissipates a little, so it's less. And then
Mhm.
so there's that. And the other thing is, I just wanted to say the Earth doesn't care uh what happens to the ice caps. It's going to survive. Uh
Mm.
it life may change as we know it, but the Earth will probably sustain life in some form or another. We may not be it and may not be around, but the planet's much more resilient than we are in as a species.
Mhm. On that cheerful note, Dr. Dalal, anything else?
Yes, we have one more question, Dr. Barnett. Is the vulnerability of Africa and South Asia correlated with population density?
Should I answer that? Is that for me?
Yeah, please. Yeah, yeah, it's for you.
Oh, yeah.
Go for it.
Not just density, no. Um, the, I mentioned the vulnerable regions in the world. There are regions that are much more unstable, not tectonically, but um, in terms of the land mass. They're just, it's like think of a mountain on a pike or something, and the pike is under the ocean. They're not as stable. There are some land masses that are, under sea level, so they're prone towards flooding. And there are, land masses that have more trees, and they have, so they have a different precipitation cycle that are more prone towards, heat precipitation and hurricanes. And, then there's the Saharan desert that is more prone towards drought. So it's not just population. We happen to have concentrated populations in, climate event prone areas. And that affects a larger amount of people. And it will also affect their abilities to live, to survive in certain areas, which will create mass migration to the north, to other more stable areas in the future. So we do see huge populations in vulnerable areas, and but that's not why climate events are happening in those areas necessarily.
Well, listen, thank you so much. It's a great presentation, and we thank Dr. Kathy Pollard for all her hard work, and also Dr. Eliza Dulal for helping to field the questions, and Dr. Kerry Graff, our um, medical director, and Dr. Susan Friedman, our director of clinical studies. And I'm going to just share my screen briefly here. We are a nonprofit. We appreciate any support you can give us. And if you'd like to aim your phone at that QR code, feel free. We'll also post the donation URL in the chat. If somebody could do that, please, that would be great. And let's thank you all for your support and for the good wishes in the chat. And anybody else on the panel have any final words?
I
Great
do.
presentation, Kathy.
Yeah.
Oh, thank you. Thank you, Dr. Graff. But I just want to thank the Rochester Lifestyle Medicine Institute for all the work that they have done over the years, and for promoting good lifestyle and good health. It's just amazing work, and so many people have benefited. So thank you. Thank you for that.
Absolutely. My pleasure, our pleasure. And we obviously couldn't do it without this amazing staff. So thank you all. And thank you to Kim Taylor, our engineer in the background, who is going to take us out here. All right. Good night, everybody.